So we will start today's lecture. So in our previous class, we have seen the equation of an A modulated wave. We have seen its corresponding frequency domain representation. We have seen the spectrum. We have seen how to plot the spectrum. We have seen how to plot the time domain in wave and to find the modulation index. Now let us go forward and try to get some more parameters from the EM wave. See, the moment we talk about wave, there is a concept of power comes into existence. Yes or no? Power. How much power? Right. Always, whenever we buy any electrical goods, right? First thing you see about its power rating. That's what, right? Power range. What power it can handle, or what is the power it can produce when it is dissipated through a particular resistor, particular load. I understood. Okay. Now, here we are talking about a signal, right? We are talking about modulated signal, that is AM wave. AM wave is nothing but a signal. Now, you must have seen in your signals and systems, there is one classification of a signal based on the power and the energy of the signal. Yes or no? Have you come across this in your signals and systems? Just a refresher for you. Signal is called as a power signal if its power is finite, right? A signal is called as an energy signal if its energy is finite, energy finite, and power infinite. Okay? For a power signal, power is finite, okay, and energy is infinite. For an energy signal, energy is finite, power is infinite. Hope you understood this. Okay? The classification of power signal and the energy signal. It's very important. Okay. See here. First, let us see what is an energy of the signal. What is an energy of the signal? Let us see what is power of a signal. Right? I understood this. What is energy of a signal? What is the power of a signal? Okay. All signals cannot be only energy signal, or all signal cannot be only power signal. Right? Some signals are energy signals, some signals are power signals. Normally, you must have heard in your signals and systems that all the periodic signal will be power signal. Yes or no? Because its energy is infinite. Right? Okay? You just have to remember this point. Okay? Now, let us see what is energy. Now, energy of a continuous time signal, x of t, energy of a continuous time signal x of t, suppose x of t is a continuous time signal, the energy is given by, E infinity is given by integration minus infinity to plus infinity, absolute value of x of t whole square. This is called as energy of a continuous time signal. Okay, suppose if your signal is discrete time, x of n, then instead of integration, what you will have? Summation. Instead of integration, you will have summation. You must have seen in your signals and system class, whenever you have a discrete time signal, all integration will be replaced by summation. So this is going to be the energy of a continuous time signal. This is going to be the energy of a discrete time signal. Okay. Similarly, what is power? What is power? Power is given by, P infinity is given by, limit at t tends to infinity. Once again, I am talking about power of a continuous time signal x of t. Okay. Continuous time signal x of t is given by limit as t tends to infinity 1 divided by 2t integration minus t by t absolute value of x of t whole square into dt. This is for continuous time signal. What about discrete time signal? You just have to change the integration to the summation. That's remember this forever. As a communication engineer, okay, you're supposed to know certain things. You never forget this. Please never forget this. Energy of a signal and a power of a signal. Wherever you go and work, these two are very important. Have you understood this? Okay, energy of a signal, power of a signal. Okay, because one and the other way in communication system, you are actually fiddling with signals, lots of signals. That's why knowing the energy and power of a signal is very important for you. Have you understood this? Okay, certain features. As I told you, we will encounter many types of signal in this many signals. See, we are actually living with signals, right? We are living with signals, so many signals in and around us. Some have infinite average power, some have infinite average power, comma energy, or both. Okay, a signal is called as energy signal. This is very important. This point is very important. A signal is called as energy signal if its energy is finite value. Okay, a signal is called as power signal if power is finite. Power is finite value. A signal can be energy signal, a power signal, energy signal, power signal, or neither type. Okay, it can be either signal and it can be either energy signal, power signal, or neither type. But signal cannot be both an energy signal and power signal. Both are not possible. Both are not possible. You cannot say a signal is both energy signal and power signal. We can say signal is either power or energy signal, or we can say it is none of that. None of that. I have understood this. Okay. These are the characteristics of a signal. These things you must already study in the signals and system. Yes or no? Just remember, study this, right? The same thing. There's no difference in that. Okay. Now, see here. If you integrate this, if you want to find out the energy, you will get a finite value, right? This signal, if you integrate this, you get a finite value. Right? This is an energy signal. Right? And all periodic signals are power signals. All periodic signals are power signals. I've understood this. Okay? Now, this is the formula. Now, let us take one example. We can find out whether the signal is energy signal or power signal. Now, see these two signals. You can easily make out by looking at the signal that the first one is the energy signal, second one is the power signal. Yes or no? So here you can say energy is finite. You can see here energy is infinite, right? Because this is actually from minus infinity to plus infinity, a periodic signal. A periodic signal, if you just take the whole square, because signal itself is existing from minus infinity to plus infinity, and if you take a square of the each and every amplitude, what will happen? It will get infinite, right? So for this signal, if you want to find energy, is it going to be finite value? Impossible. Have you understood this? What I'm trying to tell you. Hence, average power is possible, right? You take power, take minus 1 to plus 1, integrate, you get a finite value. Hence, this signal is, come on, tell me, power signal, and this signal is energy signal. All of you understood now?
Sir, can you please explain this concept?
See, these are the two signals given to you, right? If you find the energy, first find the energy of the signal, right? Then find the power of the signal, right? So if you calculate energy and power of the signal, for this you'll get energy as finite value, power as infinite value, right? You can use the same integration and you can do it, right? Similarly, this signal, if you find the energy of the signal, see it is a periodic signal, right? If you take the square of the absolute value whole square, it is going to give you infinite, right? Because this signal exists from minus infinity to plus infinity. But energy of this signal is going to be infinite, right? But power is finite. So you can integrate from -1 to take a one period. Integrate this, you get a power of the signal. So hence this signal is power signal. This signal is energy signal. Now I told you, by looking at the signal, how can we say? See, this is the periodic signal, right? You can conclude that all the periodic signals are power signals. All non-periodic signals are energy signals. Right? Because non-periodic signal, energy will be finite. Periodic signal, energy will be infinite. But power will be finite. Just remember this. This is very important. Okay? Now, let us calculate the energy of this. Let us calculate the power of this. How do you calculate? How do you calculate? Simple. See, signal A is called as energy signal. Signal A is energy signal. Signal B is a power signal. Hope all of you understood why signal A is energy signal, why signal B is power signal. All periodic signals are power signals. Just concluding, not a problem at all. Okay, with 100% assurance, we say that all periodic signals are power signals. Okay, now, can you tell me how do you write the S1 of t? I have to find out the energy of the signal, right? How do you put the S of t signal? This is, I'm just getting the refresher from your signals and systems. From -2 to 0, can you tell me what is the signal amplitude? Can you tell me what is this amplitude? It is going down from 2, right? What is the amplitude? Can you just put the signal? I'm just going back to your signals and systems. Okay. You have to tell me the answer now. The answer should come from your side, not from my side. From 0 to 4, what is the signal? 2. Okay. You can do that. See here. From -infinity for t minus infinity to -2. See here. I'm just, see, this is -infinity, see here, right? Plus infinity is that side. So from -infinity to -2, it is 0, right? From -2 to 0, it is 2. Yes or no? This is 2, right? If you take the signal, t is equal to 0, it is going to be 2, right? Then from 0 to 4, it is 2 into e to the power of -t/2. Now, how do you find the energy? This is the formula, right? This is a continuous time signal or discrete time signal. This is continuous time signal or discrete time signal. Continuous, right? Still you have doubt why you are not doing with the confident answer. This is continuous time signal, right? So what you should use? You should use integration, yes or no? Right? Yes or no? So find the energy of the signal. Right, this is the signal. Okay. Anyway, you need not worry about t minus infinity to -2 because it's 0. Okay. Now, from -2 to 0, what is the amplitude? Signal, what is signal level? Right? That is 2, right? And energy formula you have absolute value of 2 square. That is 2 square. See, 2 square into dt. So now from 0 to infinity, okay, it is 2 into e to the power of -t/2. 2 into, this is the amplitude, yes or no? This is the signal, right? A whole square, absolute whole square, okay? into dt. Now can you solve the integration? Can you solve this integration? Solve this integration. 2 square 4, right? 4 you take it outside. Integration minus 2 to 0 dt. So that is t, right? Integration of dt is t, right? So between the range minus 2 to 0 plus 2 square 4 you take it outside, then you have e to the power of minus t by 2 into 2 to get cancelled, and then you will have the integration result is going to be minus e to the power of minus t between 0 to infinity. Solve this. This is going to be 8, right? 4 into 2, 8. This is going to be 8. And this is going to be 4 into 0 minus 1. 0 minus 1. So what you will get? Energy? You will get energy as 12, right? I've understood this. You will get energy as 12. That means energy is finite. It is an energy signal. The moment you get energy finite means power will definitely infinite. I've understood this. Okay? And hence it is called as energy signal. Energy signal. And this is the energy. What is the unit of energy? Joules. What is the power of unit of power? Watts. Okay, remember that. Right? Okay. This is fine. Now, can you find out the power of the signal? Power and signal B. This is signal B. What is the power? Can you tell me what is the signal? How can you represent this S2 of t? What is S2 of t? Come on. What is S2 of t? I want an intelligent answer from this. If you have done signals and systems, come on, don't hesitate, What is exactly correct? See, 0, 1, 0, 1, right? Yes or no? Right. The signal is, you can say it is T. I've understood why it is T. Right. It is quite straightforward from the signal itself, right? See here, 0. You take this particular value. When it is 0, okay, it's 0, okay? When it is 1, it is 1. That means this particular signal is equal to T. And it's a periodic signal. The periodic signal. Have you understood? Is it fine? Okay. Now, find the power. Find the power. Of course, energy is infinity, right? If we take from minus infinity to plus infinity, signal exists everywhere, right? The infinite samples, whole square will be another infinite. So energy will be equal to infinite. What finite power is there? How do you calculate finite power? From minus 1 to plus 1, signal is T. Our formula is S square of T, 1 by T. Okay, 1 by T. 1 by T minus T by 2 to plus T by 2. Right? So you're going to take it in one of the range. So here you have range as minus 1 to plus 1. Minus 1 to plus 1. And what is the period? What is T? Capital T? Capital T is 2, right? 2. Right. If you see this, this is 2. What is this? This is T, right? This T is equal to how much? 2. Right. And then you take minus T by 2. That is minus 1 to plus 1. Okay. Integration from minus 1 to plus 1. Okay. 1 by 2. T, absolute T whole square into dt. Can you integrate this? What you will get? What is the value of power you get? Just integrate this. This is t cube by 3, right? Between plus 1 and minus 1. Just substitute the plus 1 and minus 1 you get power of a signal is equal to 1 divided by 3. Right? What is RMS power? What is RMS power? The root, right? Root means that. RMS power is root of that. Root of that will give you the RMS power. RMS power. You know the power and RMS power. Okay. So now power is equal to 1 by 3 volts. RMS power is equal to root 1 by 3 volts. That's all. Little bit integration on integration. Right? Okay. I will give you some practice problems, okay, to do. Okay. So I will just give you one problem. Very simple question. You can do it. Okay. Very simple question. Okay. So good practice for you. Did you finish? I will share the slides with you. Don't worry. Okay. Anyway, writing is better. You just writing once, reading how many times? Your teacher never said this in your schools. Huh? What is the purpose of giving impositions when you are a small class? Of course, now it is banned, right? Impositions are banned now. Right? We have been grown up with full of impositions, right? Our whole life at high school, primary schools, right? Okay, fine. I will give you one question. Okay, can you just do this? Given a signal, very simple, very simple. I'll just, you can do it in 2 steps. Do it yourself. 0, I'll just say S of t. This is 2 pi. Okay, this is not periodic signal. Okay, and the signal is sine t. Suppose if we take this as a t, sine t. Okay. Now, can you tell me whether this is a power signal or a energy signal? This is energy signal. Now I have not got the periodic form of this. So can you find the energy of the signal? Come on. Get me the answer. Now, this is another signal, okay? What is this? Minus sine t, right? This is minus sine t or? Come on. Or, what is minus sine t? Minus sine t. You can write it in terms of cos also. Doesn't matter, don't worry. This is minus sine t. Plus, what is the power? What is the energy? This is also finite signal. Okay. Find the energy, and I will give one more signal to you. Same signal, but this will be 2 into sine t. No, this is not. Sorry, this is. I don't want it to be periodic signal. Let it be non-periodic signal. Two into sine t. This I will take it as 1 of t. This I will take it as S2 of t. This I will take it as S3 of t. Okay, get me the energy in this energy. Come on. What is sine t? What is sine square t? You get sine square t, right? Right. Energy equation is sine square t. Okay, so how do you write a sine square t? In terms of 1 minus cos 2 theta by cos 2t by 2, right? Yeah, correct. Perfect. Can you integrate and get me the answer? Come on, I want to see who will give the first answer. there is a price, right? Just integration. What is the energy in first case? S1 of t. Very simple. And what is the integration range? Tell me. 0 to 2 pi. Just small integration. Try to know it. Okay, small integration. Which you all of you know about it, because you do so many things in signals and systems. You do so many things in electromagnetic fields and waves, electromagnetic theory. Everywhere integration comes, right? Okay. Who has the value? Don't worry, if you get any value, tell me. If it is wrong, doesn't matter. Don't worry, don't hesitate. Use your calculators, use your whatever, mobile, whatever, doesn't matter. There are some calculators you can solve integration, right? Which is that? Do you remember? Some calculators you can solve integration also. You don't use it. Which one? 500. Fine. Oh, good. You are the winner. Remember, I remember something I will give it definitely. A surprise. It can be anything else. Don't expect big gift. Yes, it's 5. Correct. All of you getting 5? Good. So, immediately get the answer. Okay. Don't hesitate. Doesn't matter. Don't hesitate. If it's wrong, doesn't matter. Fine. Can you tell me the second one? Is it going to change? No, right? It won't change, right? It's fine. The second one, this one. 5. What's the answer? 5 by? Okay, I will give you one more question now. It's also very easy. Okay. Simple integration, that's all, nothing else. It's just integration. You need to know only the integration, nothing else. Okay. See, signal is this is a textbook problem only. Just, it might take 5 minutes to draw the signal for me, because lots of drawing is there in this. Okay. So, you have this 0, 2, and 4, 6. Okay. You have this -2, -4, and -6. Okay, fine. Now your signal is, I'll just draw some references for this. Some references I require. But drawing the signal is quite difficult on the board, so I just need a reference. This is not a signal, okay? I'm just drawing a reference line so that I can draw these exponential signals. Okay, so I have the signal like this, okay, and I have the signal like this, and I have the signal like this. Of course, don't worry about the scale here, okay. Oh, sorry, this is not correct. I just have to see, that's where I made a mistake. It is -2, 2 plus 2. So here signal will be like, not like this. It will be something like this, okay. Similarly, you have something like this. This is the signal, okay. It repeats here, okay. And of course, it's very difficult for you to find out what is the signal. In such case, it will be given, okay. This signal is t cube, okay. This signal is t cube, okay. I will write this s of t is equal to T cube is a periodic signal. Now tell me, this is, of course, it is going to be a power signal only, right? It's going to be a power signal only. You can easily make out of the periodic signal. I said, the moment you see a periodic signal, I said it is power signal. Without any hesitations, you come to the conclusion, right? Now, what is the power? Power is equal to 1 by T integration minus T by 2 plus T by 2 S of T whole square into dt, right? Okay, what is T here? 4, right? Yes or no? T is 4, minus 2 to plus 2. Total it is 4. So minus 2 to plus 2 T cube whole square into dt. Can you get the integration? Who will give me the answer? Who will give me the answer? You will get some finite value. Integration, simple integration. Somewhere missed. until you fourth year, you remember this at least, right? After that, if you're going for masters, you may require it. If you're not going for masters, forget about integration, differentiation. You all have tools to do that. Like
So this is 1 by 2t. So
which one?
the power is equal to 1 by 2.
No, this is no. Actually, this is we are taking this period only, one period, right? If you take this is 2, right? This is 2, 1 by 2. Okay. No problem. You want to take 1 by 2, you can take. Only the little difference in the answer you get. See, t to the power of 6, right? Right? So what is the answer? Is it anybody got the answer? Tell me, no problem. Don't worry. Oh, 64 by 7. Exactly. 64 by 7. Don't worry. Tell me the answer. Don't hesitate. You are hesitating. I know. You are now ask her to be aggressive. You look very powerful, right? Be aggressive. Is it okay? Is it fine? Now, can you tell me, suppose if I take minus of g of t, what is the power? Is the power changes? No, it won't change. Right? It won't change, right? Now, suppose if I say 2 times g of t, can you tell me? It will change, right? 2 times it will change. Okay. So, this is about power and energy. Now, let us go back to our equation. Let us go back to our equation. Let us calculate the power for that signal. Let us go back to our EM wave. Where we stopped, tell me? We stopped at the equation of a EM wave, right? We have stopped at the equation of a EM wave. I'll just go where you have stopped. Somewhere here, right? Here. Here we started with efficiency. Our efficiency of an EM wave is equal to power in the side bands divided by total power. Right. into 100. Okay. Now see, this is your side band. This is called a side bands. Lower side band and upper side band. Right? If you take an entire equation, you get total power. So you have to find out total power. Total power means power in the carrier plus power in the side bands. This is total power. What is sideband power? Power in the sidebands only. Power in the sidebands only. Okay? I've understood this. Okay. Now, how do you calculate the power of the signal? Find out the power in this, right? Plus find out the power in this sidebands, right? So, of course, in this case, power in the lower sideband is equal to power in the upper sideband. Yes or no? Because if you see this equation, this is MAC by 2 cos omega C plus omega M. This is also MAC by 2 cos omega C minus omega M. Now, if you use that, this is a power signal or energy signal? This is power signal, right? This is periodic, right? Periodic signal. So hence, it is a power signal. So you have to calculate the power. If you use the same equation, which you have used now, right? Same equation, integrate this. Right, so you will definitely get it, and after integration, you get the power in the carrier wave is equal to, okay, power in the carrier wave is equal to AC square by 2. We are now taking RMS power, okay, that's RMS power is equal to AC square by 2. This is PC is equal to, assuming that you are actually going to dissipate the signal to a resistance R is equal to 1. Right? See, what is the power actually? V square by R, right? Yes or no? V square by 2R, because 1 by 2 will come there. Okay. So that means if you consider R is equal to 1, then it will be V square by 2. Okay? Yeah. See, you can use either the direct integration method or simple power calculations, because it is sinusoidal, right? If you integrate the sinusoidal, right? Definitely you get 1 here over that entire. This is cos, everywhere you have the cos term. So definitely if you integrate and check, you get this value. So power is equal to AC by root 2 whole square. Okay, this is converting your max value to the RMS value. Right, see this AC value is max value. Okay, so what is the RMS value for this? AC by root 2, right? So AC by root 2 whole square by R, whole square by R, that's the power, right? See here, if you take a general equation of power of a signal, try to understand this. This is equal to, you have one formula I square into R, right? Right? And another formula you have V square by R, not 2R, R. Right? Now, if you take RMS power, you have to take this as the RMS value. Right? In this case, it is AC. Right? Understood this. So now, what is the RMS value of this? AC by root 2 whole square by R, right? Assume R to be is equal to 1 ohm. Right? So what is the power in this equation now?
But we assume R as 1 every time?
Every time.
Okay, so
no problem. Right? Assuming this power equation you get by assuming R is equal to 1. But in practice, the resistance of the antenna will not be always 1 ohm. That's why always here we do the assumption that R is equal to 1 and we find out the power.
But it won't give the accurate power, right?
If it is sometimes in the question they say that assume R to be equal to 1. Sometimes they say antenna resistance. When antenna resistance is given, this will become R2. I have understood this. Here also R will come. Here also R will come. Here also R will come. Have you understood now? What is the power in this? Separate this. This is one term and this is MAC by 2. MAC by 2 another term. Take out this. Okay, can you tell what is the power in this? AC M by 2 divided by root 2, right? RMS value. Whole square by R. R is equal to 1. You get this value. Hope you're understanding, right? Similarly, this also same, right? Power in LSB is equal to power in USB. Hope you understand, right? So you got the power. This is the power in carrier wave. This is the power in. This is the power in upper side band. This is the power in lower side band. So you got total power. Also you got side band powers. Yes or no? What is total power now? Tell me. Total power is equal to carrier power plus side band power. Can you calculate this? Can you calculate this? Total power is equal to carrier power plus sideband power. What is sideband power? Sideband power is upper sideband power plus lower sideband power. Combine everything, right? So your efficiency is sideband power divided by total power. What is sideband power? Sideband power is this plus this, right?
LSB plus USB.
This plus this, right? That is your AC square M square by 4. What is total power? Total power is equal to carrier power plus sideband power. Are you understanding this? Can you solve this? What you will get? When you solve this, your efficiency, you get a formula M square divided by M square plus 2. Can you tell me what is M here? Come on. I told you many times last class. What is M? Modulation index. Exactly. Don't forget this. Modulation index. Modulation index.
When they give modulation index, the question should we find it out? That's the question.
If it is given, you okay. Otherwise, somewhere something should be given, right? So from where sometimes you will get A max M.
Then we have to find
Yeah. Yes. M is equal to A max minus A minimum divided by A max plus. Sometimes it will be. It's also problem. Okay. Now time over, right?
Yes.
Yeah. So I think we will continue with this in the next class. Okay. So I will just